Here we have a problem on permutation. Okay, let's go with the question. Find n if np3 equals to 60. Whenever we find some stuff like this np3, so actually it's a permutation. So permutation means like n is the given number of things. Out of the given n things, we select 3 and arrange them in a particular order. So in how many ways it can be done? So that is given by the result of this np3. In this case, it's 60. That is, we select 3 out of n things, arrange them in a particular order in 60 ways. So how many things are given? So that's given by this n. So we have to find that. Okay, so as soon as we see this kind of questions, people will start using the formula that we have for permutation. That is npr equals to n factorial by n negative r factorial. But this formula is not required over here in this problem. So actually always we don't use this formula when the r is given as a numerical value. In this case, r is given as a numerical value, that is 3. So the formula I've written over here is not required. There is a shortcut to get the stuff that is equivalent to this np3. Okay, now let me write the given equation as it is. It is np3 equals to 60. Okay, so a shortcut to get result of this one is we have to decrease this n for the next 3 consecutive integers. So I am saying this n has to be decreased for the next 3 consecutive integers because 3 is over here. That's why I'm saying this n has to be reduced for the next 3 consecutive integers. And also here you have a question. What if we have 4? This n has to be reduced for the next 4 consecutive integers. Since we have 3 over here, that is at the place of r, we have 3. So now I'm going to decrease this n for the next 3 consecutive integers. Let me start with the given value, that is n. So now to get the next consecutive integer, I have to subtract 1 from this n because I am decreasing. When I subtract 1 from this n negative 1. Okay, now to get the next consecutive integer, I have to subtract 1 from this n negative 1. N negative 1, negative 1 will be n negative 2, which is equal to 60. Okay, here we have a product of 3 consecutive integers in descending order. That is from greatest to least. So if it is possible, we can try to write this number 60 the same order. That is the product of 3 consecutive integers in descending order, so that we can compare the greatest value over here and the greatest value on the right side. You can easily get the value of n. In case if you multiply these 3 quantities over here, n negative 1, n negative 2, we'll be getting a cubic equation. It will be a little harder to solve that one. Okay, now let's try to write this 60 as a product of 3 consecutive integers in descending order. So for that, what we can do is we can decompose 60 into its prime factors. Since 60 is an even number, we can divide it by 2. When I divide it by 2, I'm getting 30. So again, it can be divided by 2 because 30 is an even number. Then I'm getting 15. Now 15 is an odd number and also it's a multiple of 3. So we can divide it by 3. Then I'm getting 5. So once we get the prime number, we have to stop the process. So 60 can be written as 2 times 2 times 3 times 5. So now we can verify 2 times 2 is 4, 4 times 2 is 12, 12 times 5 is 60. But our aim is to write the 60 as a product of 3 consecutive integers in descending order. Okay, now what we can do is like when I multiply this 2 times 2, it will become 4. Okay, here we have 3 consecutive integers, 4, 3 and 5, but not in a particular order. So we have to write in descending order. That is, we have to write the greatest number first, that is 5. Then we have to write the 4 next. Then we have to write the least number over here. Now we have written 60 as a product of 3 consecutive integers in descending order. That is from greatest to least. 5 times 4 is 20, 20 times 3 is 60. Okay, let me write the stuff over here. N times n negative 1 times n negative 2. So now the 60 can be written as 5 times 4 times 3. Okay, here on the left side, we have a product of 3 consecutive integers in descending order. The same thing we have on the right side as well. So whenever the products of 3 consecutive integers in descending order are equal, then we can equate the integers at the same position. Let me consider the greatest integer on the left side, that is clearly n. What is the greatest integer on the right side? That is 5. So n and 5 must be equal. Now I got the value of n. The value of n is 5.